Hello. In this video, we'll continue to work on the guestbook example from the last lecture. And along the way, we'll introduce some important Spring features that support web MVC applications. So this is the guestbook example from last time. We have our model class, guestbook entry with name, message, and date, and I'll be using local date type because it's better than the date type, and also we have already added free marker support for local date in this application. We have added the dependency for free marker Java 8, and we have also added this configuration property. And this is our controller. We are using dependency constructor dependency injection here, injecting a list of guestbook entries to this controller, and that guestbook entries comes from here. I think in this time I'm going to use data store because this would be a good place to add a method that gets an entry by ID. So this looks like a better way to do things than injecting a list of books, guest book entries directly. So I'm going to change this to take a data store, and I'm going to inject the data store using constructor injection, and here is going to be data store get entries. Okay, we don't need this one or this one anymore. So as I just mentioned, this one allows us to add a method that gets an entry by ID, which we'll need later on when we create the added entry operation. So we'll do that once we get there. So this is the application, and let's run it. And so hide from component, which comes from here. Okay, so it works, and right now it has one operation displaying the guestbook entries. Now let's implement the add comment part. So we know what to do. In fact, this is something that you already did in the last lab exercise. So I'm going to create a add method, and we are going to map it to get request, and this one doesn't really do anything. It simply returns a view, and I'm going to create one more. This one will be post, and this one will takes a name, takes a message, and what it will do is it will do data store get messages, get entries, add a new guest book entry, name and message, guest book entry. Did I spell this correctly? Okay, so here, import. All right, so this is the controller part, and we need to create another view. Let's do that. We want the HTML file. I'll call it add FTLH, and this one is add comment, and we'll have a form. We don't need to specify action because it's the same URL, and this one should be post, and we'll have text, and the name is name, and message will use a text area, and the text area's name is message. Then we have, let's say I want 5 rows and 60 columns, and then we have an add button, add comment, something like that. And here we will add a link to the add operation, add comment. All right, so let's see if it works. Refresh, add comment. Steve says hi, and add comment. Oh, I think I forgot to do a redirect. So we can see it is indeed added, but after adding it here, instead of returning the add form, we should do redirect to root. Okay, so let's try again. Steve says hi and that comment. Okay, so now it works. Okay, so it works, but we can do better. Why do we want to do better? Well, let's look at this part of the code. So our form has 2 fields, and here we have 2 parameters for the handler method, name and the message corresponding to the 2 fields. I don't know if you remember in the lecture when we talked about the need for a web framework, we used the example showing a form that had, I think, 8 fields. Now, imagine that you have a form with lots of fields. So we will end up doing lots of parameters in this method. And that, of course, is not very good. If we think about it, what the framework does for us right now is simply map form fields to these parameters and automatically doing some type conversion. And that, of course, is good, but it's not enough. We want the framework to do better. We want something better than a whole bunch of parameters in a method for a large form. And turns out that the framework can do that. And is something known as model binding, which basically maps data in a request to the arguments of a handler method, which is what it's doing right now. However, in addition to map to basic types like string number, date/time, like here, it can also map to objects and map directly to objects' properties. So what does that mean? It means that instead of saying string name and string message here, we can simply say guest book entry. And here we just add that entry. And if we try this again, Steve says hello, and it still works. And the reason it still works is because the framework is smart enough to take the form fields and look at the parameter of this handler method and realize that those form fields should be mapped to the properties of this object. So we no longer have to deal with individual properties, and we no longer have to create the object ourselves. The framework does that, which is quite nice. So this is, as I just mentioned, known as model bending, and we've seen examples of binding form fields to simple types like strings, numbers, and so on. And we've seen this example, which it binds to the properties of an object. And the framework can actually do even more. It can bind to nested properties, and it can bind collections as well. So for example, suppose we have a person class. The name property is a string, so we know that it's easy to bind. It's like the name property in guest book entry. But it also has a property address, which is an object by itself, having its own properties. And then we have a map of phones. For example, someone can have a mobile phone with a number, and can have an office phone with a different number, and so on. And let's say the person may also have some dogs. So suppose we want to create a registration form to register a new user like this. So hypothetically, let's say we have a controller, something with a method called register, and it takes a user object, and it's like this one, and the user object is going to come from a form. So in order for the Spring Framework to bind the form submitted data to this object, we can do something like this. So we can say in the form that we have an input that time, and this one will be bound to the name property of person, and that's simple. But if we want to bind the input to the addresses, we can do that, and all we need to do is specify address.city, and it will bind that value to the address property's city property. So in other words, we could also have something like name address.city, and the value of this input field will be bound to the city property of the address property of person. And similarly, we can create input fields like this for street, state, zip, and so on. And how about map? Well, we can create input fields that have names like phones, mobile, and this will create a map entry in the phones property with the entry key being mobile and the value being whatever value specified by the user. So in other words, we could have something like phones mobile being the name of the input, and the value of the input becomes one of the entries in the phone map. And similarly, we can specify the name attribute of an input field to be dogs, and then another input field also having the name dogs, and the values of all those input fields will end up in the dogs list. And we can even use this form to specify the index of a particular element in that list. So all in all, the model binding in the Spring framework is quite powerful, and with that, it simplifies our coding quite a bit. Now, since we are on the topic of model binding, let's talk about models in an MVC application. Models represent data in an application. Because there's data in different parts of an application, there are different types of models. The models we talked about so far are usually referred to as domain models or data models, like guestbook entry or the event class in the lab exercises. Data models represent data in the form that is stored and used internally in the application. And then there are something called binding models or input models, which represent data that comes from input, or in a web application, the data that comes from requests. And then there are the view models, which represent the data that are passed from controllers to views for display. Notice that so far in our applications, we essentially use the same model class for all three types of models. For example, in our guestbook example, we have only one model class, guestbook entry, and we use it as data models for storage. We use it as input models to take input from form submission, and we also use it as view models to pass this guestbook entry objects to a view to display. The reason of doing this is because it's convenient, and our applications are usually pretty simple, so it's kind of not worth it to create different types of model class. And also, we are not too concerned about application security because we are just doing sample code. However, in the real world, it's quite often that we need to create separate classes for different models. For example, suppose we have a domain model class called user, and this user class has an ID um, and a username password and also a Boolean field that indicates whether this user is a admin user or not. Now, if we have a registration function that allows a user to register an account, then the input model of that registration operation should only have two properties, username and password. The reason is that obviously we don't want users to generate their own user ID. We want the system to generate user IDs, unique user IDs. So when a user register, they should pick their username and password, but not their ID. And also, of course, we don't want users to designate themselves to be administrators. So the registration input should exclude both ID and Boolean is admin field. So this would be an example of an input model that differs from the data model because the input shouldn't have certain fields. And similarly, if we want to have a display user operation and the user view model may not have password fields because we probably don't want to display the user's password. So a user view model may only have ID, username, and is admin. So this would be an example of a view model differing from a data model. So in real world applications, we can come up with lots of this type of examples. So beware of the differences between data models, view models, and input models / binding models. Although in our simple examples, we usually don't distinguish them, but do understand that they're different and will develop more sophisticated applications. You should develop different classes for the different models. Okay, so now that we know about models and model binding, let's implement edit entry operation. And I like to use this operation to illustrate a few additional Spring features, path variable, form binding, and validation. So let's first implement the operation, and let's say we have edit operation, and this edit operation needs to take ID, and this is where we want to implement the method that returns an entry given an ID. So this one will return guestbook entry, and I'll call it get entry, and it takes an ID, and we'll say for each guestbook entry, if entry get ID is ID, will return that entry, and otherwise we'll return null. And so then here we can simply say we need a model to pass that entry to the view. So So what do we do? Let's say model and attribute, and we pass an entry, and we'll say data store and entry by this ID. Okay, so this one will be the get part, and this one, let's do the post part. So the post part, how do we do it? So it should be mapped to edit, and in this case, we're going to get a new entry. So this one is a new entry, and we still need to get the old entry. So the old entry is this one, and then let's say the old entry will do new entry get name message, and then we do a redirect, something like that. Okay, let's we'll see if it works, and let's add the template. So this template will be called edit comment, no, add entry, and it's going to be a post, and this one is name, and this one will have the value entry.name, and this one is area, and the area will have entry.message, something like that. And instead of things add comment, we'll say save. Yeah, we'll say just say save. Okay, so that seems to be the edit part, and let's change this a little bit. Let's add one more column, and we'll say edit ID is entry.id. Okay, something like that. All right, let's see if it works. We refresh, and we edit. So it gets the ID 1, but it's not showing anything in the form. That's not good. Let's see if our code is correct. Now our code, there's nothing in there. So why it says edit comment? I think maybe I returned the wrong view. Let me see. Where is it? Here. Yes, I returned the wrong view. I should return edit, not add. So let's try again. Okay, so this time it's correct. I think it's probably because I included additional space here. So it's better to to do this. All right, so now it seems to work. Let's say we have Tom2 and just say hello and save, and it changed to Tom2 hello. Okay, so that works. And without learning anything new, we can implement this edit entry information. Um, but we can make it better by using some additional Spring Framework features. The first thing I want to use is a path variable. So notice that if we click edit, the URL is edit question mark ID is 1. So we pass ID as a request parameter, which is perfectly fine. However, oftentimes we want to also use so-called path variable. A path variable is something like this. In Canvas, for example, if we want to go to a course, the URL is courses slash and then course ID. If we look at this URL, it looks kind of better than question mark ID equals to something. Right? It's purely aesthetic, but still, oftentimes the URL looks nicer and more readable and makes more sense that way. So there's no easy way to do this using Servlet API. However, in Spring Framework, we can do this easily using the so-called path variable. All we need to do is we say we map the path to a path pattern, and that pattern include variables in it. So this one basically says for URL patterns that starts with slash edit slash followed by something, and we'll treat that something as an ID and convert it into an integer. And we will need to annotate this parameter in the handler method using the path variable annotation to tell framework that this one should come from the path rather than from request parameter. If we do that, it will still work, but the URL would look nicer. And so what we do is we'll do this, and we'll say this one should be a path variable. And we'll do the same thing here. And we'll change the URL a little bit. Instead of saying edit question mark, we simply say edit slash entry ID. And let's see. So we refresh and we click edit, and notice that the URL now says edit slash 1, and again we change it to tab2 hello, and it still works. But now the URL contains a path variable. So that's pretty simple and pretty easy to do. Now, can we do even better? Yes, we can also use something called form binding. As shown in this diagram, just like we can bind data submitted from a form to an object, what we call model binding, we can also do the other way around. We can also bind data in an object to a form using form binding. To do form binding, we need framework support for the template engine we use. In Spring, it's a set of free marker macros called input macros. So if we look at the documentation, is is these things, the Spring.message, uh, the Spring form hidden input, Spring form text area, and so on and so forth. Macro is a way in FreeMarker to create user-defined directives. So technically, I think those things should be called Spring input directives for FreeMarker or something. But Spring calls them input macros, so we'll call them input macros. By the way, since Spring is open source, we can actually see the source code of those macros. If you go to this link, we can actually see those macros. For example, form input macro, or looks like this. Having source code is great because source code kind of serves as the ultimate documentation. If we are unsure about how to use these macros, we can actually check out their source code and see how they are supposed to be used. And they also serve as good examples of creating user-defined directives in FreeMarker if we ever need to do that. Now, let's look at how we can use this. First, we need to import them into the FreeMarker template with the import directive. So that's the import directive, and we need to put it in the template. So it's kind of like an import statement in Java that imports a library, and this one basically says we're going to import the macro library called spring.ftl, and we will refer to this library as Spring, and any macro inside this library will be called Spring dot and then the macro name. So the one we are going to use, the ones we are going to use are two. We are going to use a form input macro, and we are going to use a form text area macro. Based on the name, you can kind of tell that they are they correspond to an input field and a text area in HTML. So what we do is we will replace this one with Spring input. Is it called input text? Oh, form input. So form input, and if we look at the source code, we can see that it takes, we can think of this as method calls, and it takes three parameters: path, attributes, and field type. The attributes and the field type parameters all have default values, so we can omit those if we want, but the path we have to specify. So the path here would be entry.name, and this path, as you can kind of guess, is a path to the property that is bound to this input, and it goes to the entry object name property, and that property is bound to this input. Very importantly, notice that FreeMarker directives use XML syntax, so we have to self-close this tag. Unlike HTML input, we can do this. But if we do this in free marker, it will give us an error. So this the closing tag is important. Now, similarly, we can do a Spring form text area, and that will replace this one. So this Spring form text area, once again, it takes a path, and that path is a path to the message property. And most of this Spring input macros takes a second parameter called attributes, and these attributes are basically HTML tag attributes that you want to add. For example, for a form text area, I want to specify the number of rows and columns. So I'm going to specify the second parameter, and I'll say rows is 5 rows and columns is 60 columns, something like that. So now we have this form that bound two properties to two fields. So let's give it a try, and let's go back, refresh, and edit. And Tomcat says hello world, and save, and now it still works. So it works, but well, actually, let's see the HTML generated by those two macros first. Let's look at the page in this browser. And if we do a view source, we can see the HTML text generated by those two Spring input macros. It generates an input text input with an ID, with a name, with a value. And here it generates a text area with ID name. And notice that anything inside here is copied as additional attribute for this tag, even the single quotes here. So this is what we can do with Spring input macros. And at this point, you may be wondering, how is this better than what we did before without using the macros, where we simply say entry dot name, put it inside interpolation and so on. So, well, first of all, you certainly do not have to use this input macros. What we did before worked, and you could keep doing that if you want. However, you will eventually find that certain form controls are hard to deal with than others. In particular, if you have to use checkboxes or selection lists, you'll find that it takes quite some work to create them in a state that is consistent with the values in a model object. And those input macros make it a lot easier to deal with those form controls. Another reason is that we sometimes need to display validation errors, and that again can be quite complicated. And Spring provides show errors. Where is show errors? Yeah, it provides a show errors macro that makes displaying validation errors quite a bit easier. Now, speaking of validation, we often need to do input validation so we can be sure that the information a user enters into a form is valid. we can do input validation on the client side using JavaScript. Because the data is checked in the browser, it doesn't need to be sent to the server, and if there's any error, the error doesn't need to send back from the server to the client. So validation on the client side is very fast because it doesn't use server resources. It's also very scalable, meaning that the server can serve many clients at the same time. Unfortunately, client-side validation has a very big shortcoming. It can be easily bypassed. A malicious user can simply disable JavaScript in a browser, or even just manually craft a HTML request without using a form. So in the situations where data integrity is crucial, we'll have to do server-side validation. Although input validation may sound simple, it can get quite complicated because there could be multiple errors in a form submission. So we want to find all the errors and then show the error messages all at once to the user. We don't want to show the errors one by one, so the user have to repeatedly refill a form. And because there could be multiple errors in a form submission, we also need to be able to identify which error is caused by which field. And if our web application is used in different countries like Facebook, then we need to support multiple languages for error messages. And also, when we send the form back to the user uh, to correct the errors, we need to remember the user input so that user don't have to retype everything, especially for those form fields that are correct. And last but not least, we often want to separate validation code from application code because otherwise, when they mix together, it's hard to manage. So all this basically says that we need some kind of framework support rather than having to do all this from scratch ourselves. Spring integrates some Java validation libraries that make common validation tasks easy to do. To use those libraries, we need to add the validation dependency when we create a Spring Boot application. So let's quickly create one and see what it looks like. We'll do a Spring Starter project and okay, so I guess I'm going to call it my lab 8, probably the project name I used last time. And so far we have selected FreeMarker, DevTools, and Spring Web. If we want to do validation, we need to choose one more. It's under IO. It's called, yeah, it's just called validation. So if we create that project, so this will include the validation dependency, which is this one. So what if we already have a project created? All we need to do if we want to add the validation stuff is to add this dependency to the pom.xml file. So I'll just copy this one and then paste it into guestbook, and I'll put it here since there happens to be an empty line there. And that's it. Now we have validation in the project. So how do we use this thing? This validation library implements the Jakarta bin validation 2.0 specification. So if we look at it, well, it's a long specification, but for us, the most important thing is the validation annotations. So if we scroll down, it's in chapter 8. So there's annotations. Now, not now, min max, and so on and so forth. So if you look at these annotations, you can kind of tell what they do, right? For example, not now means a field cannot be null, and min means a field must have at least a minimum value. Past means a date time object must be a date time in the past, and email must be an email. Not empty means not null, and not empty string, and not blank means not null, not empty string, and not just white space characters. So this one ensures that a field must have at least one non-white space characters, so on and so forth. So here you can see some samples of using this annotations. For example, let's say digits, right? For example, so digits we can put it on number field, and this one will ensure that it has 6 integer digits and 2 digits after the decimal points and so on. So it max at most 10, at least 5 usernames not known, and date birthday must be in the past, and so on and so forth. So for our example, we'll just do something simple. We'll just say name cannot be blank. Right? Yeah, so notice once again there are 2 not blank, one from the validation package, one from Hibernate validator package. We want the validation one. And let's say message cannot be null, cannot be blank as well. So this tool basically says name and the message cannot be blank, but we still need to perform validation at some point, and that some point would be here when a form is submitted. So what we need to do is we need to add a valid annotation here. So this annotation basically invokes validation on this input model new entry. And then we need to store the validation results somewhere, and that's stored in another argument to the handler method with the type binding result. And typically we say if a result has errors, then we'll send the user back to the form. And if we get past this if statement, then meaning that there's no validation errors, then we can get the entry, we can set the name and message, and then do the redirect. So that's how we do that's how we do validation. And let's see if this thing works. So we'll run this, and we'll go back, refresh, and then let's say edit. And here, if I say Tom2, it will work. And if I say empty name is getting an exception. So why is giving me exception? Oh, okay. So so this is where we need to add one more annotation, and that's called model attribute entry. Okay, I think now it should work. So the important part is this: neither binding result or plain target object for bin name entry available as request attribute, and so on and so forth. So what this one means is that when we when we send the user back to the form, and the form is missing a model object called entry. Now the reason for that is if we don't specify this, the Spring Framework will derive a model object name based on the class name. So it will take this one and call it guestbook entry with lowercase g, and send that one to the form. And however, this form requires a model object called entry, and it only gets one called guestbook entry, and that's why it's giving us an error. So here we'll have to explicitly say this model object should be called entry, and now I think it will work. Let's see. So refresh and edit. We'll remove Tom and save. And now, as we can see, the exception is no more, and we are sent back to the form because name is blank. And if we put something not blank in there, it will work. So one more thing for this example is we certainly want to show an error message here, because otherwise the user will get confused why I click save and nothing seems to be happening. So that can be done using the show errors macro. So this is how it looks in a view template. We have the input macro that binds to a particular property, and immediately follow that we can do a show errors. And so if any error occurred associated with that property, error message will be displayed here. If we look at the source code of show errors, we can see that show errors takes two parameters. One is separator, which doesn't have a default value, and the second one is class or style, which has a default value of empty string, meaning that we can omit the second one, but the first one we have to specify. The reason it always takes a separator is that there could be multiple errors associated with one field. So if it needs to display more than one error message, then they will be separated by a new line break. So let's do that here. We will put screen show errors here, and it takes a line break as a separator. And, right. So remember to close the tag, and we'll do the same thing for the message part. Okay, so yeah, let's try again, and here refresh, edit. If I remove Steve and say save, now it says must not be blank. So this is a default error message, and if we want, we can add a little bit more to it. So we can add a custom message here that says name is required. So instead of displaying the default message, it will display this message. And also we could add a little bit styling to this. By default, it's simply a bolded message. And let's say instead of bolded, we want red. So we can put here, and this one is basically the second arguments to the show errors macro, and let's try again, and empty name, and now it says name is required in red. So yeah, that's how validation works. If you look at the code, there's not a whole lot of code need to be written. We add a couple of annotations, another couple of annotations here. That's pretty much it, and then we can do show errors, and everything kind of works nicely. We do need to be careful with a few things, otherwise we end up with some problems that are very difficult to debug. The potential pitfalls are mainly here. So because there could be multiple input models, for example, we could have a new entry and then another input model and then another input model. So the first thing we need to make sure is that the binding result must be immediately after the validated input model in the parameter list of the method. In other words, we need to say guestbook entry, new entry, and then immediately binding result. We cannot have another parameter in between. If we have multiple input models, it will be input model, binding result, input model, binding result, and so on. And secondly, because there could be multiple input models, binding result is associated with the input model by name. And once again, the name is derived from its class name. So so here, if we don't specify model attribute, the model name will be under a lowercase g guest book entry, and that will cause problem because this one looks for a model attribute called entry. So because of that, we need model attribute annotation to specify the name. So these few things are kind of easy to miss, but if you got wrong one of them, validation won't work, and it's hard to debug. So keep these things in mind. Okay, so I think that's about it. As an exercise, you can add form binding and validation to add comment as well. So the way to do that is basically make it look like the edit operation. So for example, here, instead of just return add, we can pass a model of an empty entry object like this one. So in other words, we can say model and then model add attribute new guestbook entry. So we can pass empty guestbook entry as the model object, and then here in post we can do validation and so on. So I'll leave that as an exercise. And that is it for today. Thank you, and see you in the next video.